Hey friends, welcome to my channel. Let's have a look at problem 1522, diameter of N-Ary tree. So in this video, we're going to share a solution based on recursion. So this is actually in parallel to problem 543. So you are welcome to check out the corresponding video in my channel. So let's first look at the statement. So given a root of an N-Ary tree, so we need to compute the length of the diameter of the tree. The diameter of an N-Ary tree is the length of the longest path between any two nodes in the tree. So this path may not pass through the root. So this sentence actually provides important information or give us a hint for how to do the problem. So here are some examples. So in example 1, so the output is 3. So one of the possible paths is marked in red. So actually the path is not unique. For example, we can also see 5, 3, 1, 4 or 6, 3, 1, 2, 6, 3, 1, 4. So in example 2, the output is 4 and one of the paths is marked in red. And this example actually demonstrates that so the longest path may not pass through the root itself. So in example 3, so the output is 7. So one path is marked in red. So actually there is another path, for example 14, 11, 7, 3, 1, 5, 9, and 13. So let's also look at the constraints on this problem. First, the depth of the N-Ary tree is less than or equal to 1000. And second, the total number of nodes is between 1 and 10 to the power of 4. So these two constraints actually confine the size of the problem we are looking at. So with that said, we are ready to do the analysis for this problem. First, the method is based on recursion. So we are going to use exactly the same idea as those in problem 543. So the difference here lies in that the tree here is N-Ary tree. Let's look at the idea. So for each node or tree U, so we are going to compute two pieces of information. So the first piece of information is DU. So we interpret this item as the number of nodes in the path from U to the deepest leaf in the tree U. So another piece of information is PU. So this interpretation is a little bit delicate. So here we interpreted PU as the number of nodes in the longest possible path, including the one passing through U in the original full tree. So that's the interpretation for PU. So next, we're ready to give the recursion relation. So the recursion relation is actually also the same as the previous problem, but it just needs some slight adjustment. So assume that U is the root and it has children V0, V1 up to Vn, and that we have known dvi, pvi. In other words, we have known the corresponding information for the subtrees. And then we want to get the information for the tree U. So first, du is equal to this expression. So let's look at the items in the max or in the parentheses. So dvi plus 1. So dvi means the number of nodes from the subtree vi to a deepest leaf. Then if we plus 1, actually we include the root u itself. So if we take maximum, then this maximum is nothing but the largest number of nodes from u to the deepest leaf. So this is the item 1 here. So this part is relatively easy. So next, let's look at how to determine P of U. So first, let's assume the largest two node to deepest leaf nodes numbers are given by dv0 and dv1. So this actually is just for convenience, so without loss of generality. So we can get these two numbers by just sorting this dv0, dv1 up to dvn from large to small. Then Pu equals the maximum of these expressions in the parentheses. So there are two parts actually. First part is PV0, PV1 up to PVn. So this part actually corresponding to the number of nodes in the longest possible path, including those passing through V0, V1 up to Vm. So the last piece actually is the number of nodes in the longest possible path passing through U. So here the dv0 plus dv1 are the number of nodes in the two subtrees, and 1 it means that we add or include the U, the root itself. So that's the expression. So notice that if we have only one child, so we just need to add one of them, right? 1. So before, actually up to now, we can write code, but let's look at the two extensions here. So first, actually, it might be good to look at the analysis for Leetcode 543. So the diameter of a binary tree, so binary. And also the N-Ary Tree and data structure actually plays a role when we implement the trial abstract data type. For example, if we want to store strings of prefixes, so it's good to try to implement a trial abstract data structure and solve some problems in Leetcode, for example. So with that said, we are ready to write the code. So we're going to split the code into two parts. The first part is the main work, so the hyperfunction, to compute the two pieces of information for each node. So I'm going to use a function signature like this, traverse, the root. So essentially we are doing N-Ary Tree traversal, right? So in order to write this function in a recursion format, let's first look at a base case, that is, or stop condition, if not root. So in other words, the root is null, so we're going to return 0, 0. And this is actually very intuitive because we do not have any nodes at all. So if the root is not null, we're going to look at the information corresponding to the subtrees. In other words, we want to get those information here, right, corresponding to this highlighted sentence. So for this, we're going to do traverse for each of the nodes, for node in root children, if node, right, if the node is not null. So actually the root can have no children. So in this case, the information list is empty, so if not info. So we're going to return 1, 1 because we just have a single node tree, that is the root itself. So we have 1, 1. So that's actually very direct. So next we're going to consider the generic case or the general logic. So for this, let me first do some sorting in order to make the update easier. So we are going to sort reversely. So we are going to put this reverse flag to be true. And then the thing we are going to sort is info item. So the first piece of information, that is the number of nodes from the subtree to deepest leaf. So for I in range, let's call it M. So let's use this M to be the length of info. So that's one part. So first, let's get the information, the first part of information for the root itself. So this actually is 1 plus the maximum possible of this one. But we have sorted that, so we're going to just use temp 0. So notice that this temp array contains at least one entry, so this temp 0 is always valid. So this is the first part. And then let's look at the second part. So we're going to get this information. So here. So we need two parts of comparison. First, let's get the maximum of these, and then compare the root passing through the path passing through the root itself. So for this, let's first do info 2 equals maximal. So let's use our iterator. So info item for the second piece of information, that is for I in range M. So this information contains the number of nodes in all the including all the passes passing through the subtree nodes, V0 up to Vn, right? If we use above notations, and then we need also to consider the longest path passing through the root. So in this case, we're going to do another max operation. So the previous state of info2, and then plus the largest possible number of nodes in the corresponding path passing through the root. That is 1. So we include the root node itself, then plus the temp 2. So we're going to use a sum here. So this actually computes the number of nodes in the two largest or longest subtree passes. Then so that's it, right? So now we are ready to return info1 and info2. So that's the bulk of work for the traverse hyperfunction. So next we're going to prepare the return. So in this case, let's first call this traverse function. So traverse from the root, and then notice that the result actually will give us the largest possible number of nodes in the corresponding longest path. Then we're going to return the length. So we're going to return result minus 1 if result is larger than 0. Otherwise, we're going to return 0. So this actually consists of a full solution for this problem. So let's first do a special case check. Yeah, it passes the first example. Now let's do a generic case check. So yeah, it passes all the generic cases. So here, let's give a quick overview of the solution. So actually, the solution consists of two parts. The first part is the bulk of the work. So for each of the root, we compute two pieces of information. So one is the root to deepest leaf path number of nodes, and another is the largest number of nodes in the longest possible routes, including the one passing through the root itself. So with that said, I guess that's about it for this video. Thank you very much.